Hello students, welcome back to the math class. In our last class, we have discussed about the right circular cylinder, and in this class, we will discuss about surface area of a right circular cone. Okay? So far, we have been generating solids by stacking of congruent figures. Incidentally, such figures are called prisms. Now, let us look at another kind of solid which is not a prism. These kinds of solids are called pyramids. Let us see how we can generate them. Students, there is an activity given in your book and let us discuss that and hope you can do it by yourself. Okay? The activity says, cut out a right angled triangle ABC, right angled at B, paste a long thick string along one of the perpendicular sides, say AB of the triangle. You can refer to figure 13.13a. Hold the string with your hands on either sides of the triangle and rotate the triangle about the string a number of times. What happens? Do you recognize the shape that the triangle is forming as it rotates round the string? Does it remind you of the time you had eaten an ice cream heaped into a container of that shape? You can refer figure 13.13 C and D. This is called a right circular cone. In figure 13.13 C of the right circular cone, the point A is called the vertex, AB is called the height, BC is called the radius and AC is called the slant height of the cone. Here B will be the center of circular base of the cone. The height, radius and slant height of the cone are usually denoted by H, R and L respectively. Once again, let us see what kind of cone we cannot call a right circular cone. Okay, here you are. What you see in figure 13.14, these figures are not right circular cones because in A, the line joining its vertex to the center of its base is not at right angle to the base, and in figure B, the base is not circular. As in the case of cylinder, since we will be studying only about right circular cones, remember that by cone in this chapter we shall mean a right circular cone. Okay? Students, now there is another activity for you. Just cut out a neatly made paper cone that does not have any overlapped paper straight along its side and opening it out to see the shape of paper that forms the surface of the cone. The line along which you cut the cone is the slant height of the cone, which is represented by L. It looks like a part of a round cake, isn't it? If you now bring the sides marked A and B at the tips together, you can see that the curved portion of figure 13.15 C will form the circular base of the cone. If the paper like the cone in figure 13.15 C is now cut into hundreds of little pieces along the lines drawn from the point O, each cut portion is almost a small triangle whose height is the slant height L of the cone. Students, now the area of each triangle is half into base of each triangle into height, which is nothing but L in this case. So, area of the entire piece of paper is sum of the areas of all the triangles. Students, so the area should be half B1 into L plus half into B2 into L plus half into B3 into L and so on. That means half into BL, it is area of each triangle, because here as the slant height is same for each triangle, that's why L remains constant, but each triangle has different base. That's why in the formula here B1, B2, B3 are given. So when we combine all these, we get half L whole multiplied by B1 plus B2 plus B3 plus so on. That means all the bases of the triangle are to be added and multiplied to half of L. So it gives us a formula half into L into length of entire curved boundary. Why is it so? Students, bases are different. When the bases are combined, they will give us the length of entire curved boundary. You can refer figure 13.15c. Okay. So, what is the length of entire curved boundary? Students, the curved portion of the figure makes of the perimeter of the base of the cone, and the circumference of the base of the cone is 2 pi r, where r is the base radius of the cone. So, the curved surface area of a cone is equal to half into L into 2 pi r. So, that is pi r L. Okay. So, what is the formula for curved surface area of a cone? Pi r L, where r is the base radius and L is the slant height. Note that L square is equal to r square plus h square. Why is it so? Let us find out. Okay. Students, let us now see how can we find out L. Okay. So, this is your radius of the base, that is represented by r. Okay. And this is the height of the cone, and this is the slant height L. So, we know that the height is perpendicular to the base, that means this is 90 degree. So, just observe that if I name it as A, B and C, triangle ABC is a right angled triangle. That means L is the hypotenuse and H is the height, R is the base of that right angled triangle. So, we know that in a right angled triangle, according to Pythagoras theorem, hypotenuse square is equal to base square plus height square. So, as per that, L square is equal to R square plus S square. Okay. So, students, from this only we can find out the length of L. So, L is equal to square root of R square plus H square. Okay. Now, if the base of the cone is to be closed, then a circular piece of paper of radius r is also required, whose area is pi r square. This is for a open cone. That means this part is open now. See, this is a circular surface, isn't it? So, this base is circular. So, if I close it, then I need that much area to cover. So, what is the area of a circle? Area of circle is equal to pi r square. That means, if I need to close the base, I have to have pi r square of area. Okay. That means, when I need to find out the total surface area, I have to add area of the base to the curved surface area. Okay. So, let us find out what should be the formula for total surface area of a cone? Okay. So, students, what should be the total surface area of the cone? Of a cone is equal to, first we have found out the curved surface area, that is pi r L, and area of the base, that is pi r square. So, if I take pi r as common, I am left with L plus r. So, this is the formula for total surface area of a cone. Hope you understand this. Students, let us now discuss example 4. It says, find the curved surface area of a right circular cone whose slant height is 10 centimeter and base radius is 7 centimeter. Okay? So, let us now discuss the solution. We know the curved surface area for a cone is pi r L, and here the radius is given as 7 centimeter. So, r is equal to 7 centimeter. What else? The slant height is also given. What is it? It is 10 centimeter. So, L is equal to 10 centimeter. When we substitute the value, so the curved surface area is equal to pi r L, that means 22 by 7 into 7 into 10 is equal to 220 centimeter square. So, in this way we have found out the curved surface area of the circular cone. Okay. Hope you understand this. Students, let us now discuss example 5. It says, the height of a cone is 16 centimeter and its base radius is 12 centimeter. Find the curved surface area and the total surface area of the cone. Okay. And the question is instructing that pi should be taken as 3.14. Okay. So, let us now begin with the solution. Here height is given as 16 centimeter and the radius is given as 12 centimeter. So, h is equal to 16 centimeter and r is equal to 12 centimeter. Students, to find out the curved surface area, we need to know about the slant height, because curved surface area is equal to pi r L. Here we have r and h. So, let us find out L. So, what we know about L? L is equal to square root of h square plus r square. So, it is 16 square plus 12 square. Okay, 16 square plus 12 square. 256 plus 144. 20 centimeter. So, now we have found out the value of L to be 20 centimeter. Let us put these values in the formula for curved surface area and find out the curved surface area of the cone. So, students, now we have r is equal to 12 centimeter and L is equal to 20 centimeter. So, curved surface area is equal to pi r L, that is equal to 3.14 into 12 into 20 or 314 by 100 into 20. When we calculate, it will come up to 753.6 centimeter square. Okay. So, curved surface area of the cone is 753.6 centimeter square. Now, let us find out the total surface area. What is total surface area? Is equal to pi r L plus pi r square. Pi r L plus pi r square, or we can write pi r L plus r. So, that is equal to 3.14 into 12 whole multiplied by 20 plus 12. 3.14 into 12 into 32. When we calculate, it comes up to 1205.76 centimeter square. So, we have found that total surface area of the given cone to be 1205.76 centimeter square. Hope you have understood this example. Students, let us now discuss example 6. It says a corn cob, as you can see in figure 13.17, shaped somewhat like a cone, has the radius of its broadest end as 2.1 centimeter and length, that is height, as 20 centimeter. If each 1 centimeter square of the surface of the cob carries an average of 4 grains, find how many grains you would find on the entire cob. Okay. Let us now discuss the solution. Since the grains of corn are found only on the curved surface of the corn cob, we would need to know the curved surface area of the corn cob to find the total number of grains on it. In this question, we are given the height of the cone, so we need to find its slant height. Okay. So, let us now find the slant height. So, students, as we know, slant height L is equal to square root of r square plus s square. R is given as 2.1 centimeter. So, 2.1 square plus height is of 20 centimeter. So, 20 square. Okay. So, when we calculate, it will be 404.41 square root of 404.41 or 20.11 centimeter. Okay. Therefore, the curved surface area, let us now find out the curved surface area. Curved surface area is equal to pi r L, that is 22 by 7 into 2.1 into 20.11. So, when we calculate, we will have the result 132.73 centimeter square. Okay. Why? See, it will be about 132.726 centimeter square and the approximate value will be 132.73 centimeter square. So, number of grains of corn on 1 centimeter square of the surface of the corn cob is 4. Therefore, number of grains on the entire curved surface of the cob will be, yes, 132.73 into 4. 132.73 into 4, that will be equal to 530.92, or we can say 531. It is an approximate value. Okay. So, there would be approximately 531 grains of corn on the cob. Okay. Hope you understand the example. Students, let us now discuss exercise 13.3. Here we will assume pi as 22 by 7 unless stated otherwise. Okay. So, when the question says that pi is equal to 3.14, then we will take pi is equal to 3.14 for our calculation. Otherwise, pi is equal to 22 by 7 for this exercise. Okay. So, let us now solve question number 1. What it says? It says diameter of the base of a cone is 10.5 centimeter and its slant height is 10 centimeter. Find its curved surface area. So, let us discuss the solution. Okay. So, as per the question, the diameter of the base of cone is 10.5. So, d is equal to 10.5 centimeter. So, r will be d by 2, that is 10.5 by 2, or it is 5.25 centimeter. So, student, the slant height is given as 10 centimeter. So, L will be 10 centimeter. So, what is the curved surface area? Curved surface area is equal to pi r L. that is equal to 22 by 7 into 5.25 into 10. Okay. So, when we calculate, we will get a value that will be equal to 165 centimeter square. So, this is the curved surface area that we were needed to find out. Hope you understand the solution. Students, let us now solve question number 2. Okay. It says, find the total surface area of a cone if its slant height is 21 meter and diameter of its base is 24 meter. So, let us solve the question. What is the given data? Slant height is 21 meter. So, L is equal to 21 meter and the diameter of the base is 24 meter. So, D is equal to 24 meter. That means R is equal to D by 2, that is 24 by 2 or 12 centimeter. Okay. So, we have our radius and slant height and it is asked that we need to find out total surface area of the cone. So, for total surface area of the cone, the formula is total surface area is equal to, what is the formula? Do you remember? It is pi r L plus r. So, we just need to substitute the values, that is 22 by 7 into 12 whole multiplied by 21 plus 12, that is equal to 22 by 7 into 12 into 33. Okay. So, when we calculate, after calculation we will have a value that is equal to 1244.57 centimeter square. So, this is the desired total surface area of the cone. Hope you understand the solution for this question. Students, let us now discuss question number 3. It says curved surface area of a cone is 308 centimeter square and its slant height is 14 centimeter. Find radius of the base and total surface area of the cone. Okay. So, let us solve the question. The given data is curved surface area. Curved surface area is given as 308 centimeter square. Okay. And slant height, that is L, is equal to 14 centimeter. Fine. Find radius of the base. Okay. So, we know that curved surface area is equal to pi r L, that is equal to 308 centimeter square. That implies 22 by 7 into r into 14, that is equal to 308 centimeter square. That implies r is equal to 308 into 7 divided by 22 into 14. 7 2s are okay. Now, that is 7 centimeter. So, we have found that radius of the cone is 7 centimeter. Fine. Let us now find out the total surface area of the cone. So, this is bit 1. Bit 2 asks for total surface area. Total surface area, for total surface area, the formula is pi r whole multiplied by L plus r. Let us substitute the value. 22 by 7 into 7 whole multiplied by 14 plus 7. So, this is equal to 22 into 21. So, 462 centimeter square. Okay, students, hope you understand the solution for this question. Students, let us now solve question number 4. Okay, it says a conical tent is 10 meter high and the radius of its base is 24 meter. Find slant height of the tent and cost of the canvas required to make the tent if the cost of 1 meter square canvas is rupees 70. Okay. Let us now solve the question. What is the given data? As per the data, a conical tent is 10 meter high. So, height is 10 meter and the radius of its base is 24 meter. So, r is equal to 24 meter. So, let us find out the solution for bit 1. It asks for slant height of the tent. So, L is equal to r square plus a square root, that is 24 square plus 10 square (576) plus 100. Okay. So, what is the square root of 676? That is 26. So, the slant height of the cone is 26 meter. Fine. So, let us find the solution for bit 2. Okay. It asks for curved surface area of the cone. So, for curved surface area, we need R and L. We have R and we have L. So, curved surface area is equal to pi R L, that is 22 by 7 into 24 into 26. Fine. So, this is equal to 13728 by 7 meter square. Fine. This is the curved surface area which is in fraction form. So, it is given that cost of one canvas is rupees 70. Fine. Cost of one canvas is rupees 70 and we need to find out the total cost. Okay. Students, cost of canvas is rupees 70 per 1 meter square. So, let us find the total cost. So, costs per meter square is rupees 70. That implies total cost is equal to 13728 divided by 7 into 70. That is why I did not calculate the decimal for this value, because now it will be easier. So, this is 137,280, that means 1,37,280 rupees. Hence, the cost of the canvas required to make such a tent is rupees 1,37,280. Hope you understand the solution for question number 4. Students, this is the end for today's session. In this session, we have discussed some concepts about surface area and volume, and we have gone through some examples and solved some questions. In our next class, we will discuss some more concepts about surface area and volume. Till then, just keep enjoying with maths, keep practicing, keep smiling. Thank you.